Hello, I'm Owen and welcome to my shed. Here I like to do electronics and robotics and coding, things like that. It's a bank holiday weekend here in the UK, and recently I've been using this library called Simple FOC. It's a library for Arduino. It works with lots of boards. So with this library you typically have 4 bits of hardware. You'd have a brushless DC motor, and then you'd put an encoder which measures angle position on the motor. You'd have a driver board like this Simple FOC shield, and then like something like a Arduino Uno or some other board like ESP32. So I thought I'd like to perhaps talk about this library, but in the context of PlatformIO IDE. So most people use Simple FOC with Arduino IDE. I use PlatformIO IDE. I think it's a lot better, and hopefully during this tutorial I'll explain why. Some people struggle with PlatformIO, just getting going, setting up projects, getting libraries sorted and adding boards and things like that. So I thought that's what I'd concentrate on in this tutorial. So basically what we'll be doing is we'll be installing VSCode, which is basically an IDE for developers. We'll then be installing the PlatformIO plugin and also a C++ plugin, which gives you sort of IntelliSense and things like that. We'll be installing the library, the Simple FOC library, and a few of its dependents, and we'll be doing it on a couple of boards. So the first one is an ESP32. That's the Simple FOC shield on the right there, and the second one will be, I think they're gimbal controllers. I think this is a BGC gimbal controller, about 10 quid. They're not very powerful from a processor perspective, but they've got, you know, dual capability, dual drivers for 2 motors. So just to get started, basically installation process. So on Windows you'd be going to the website, and same thing with Mac probably, to install VS Code, but I'm on Ubuntu, so I'll install VS Code using apt on Ubuntu. It'll take 5 or 10 seconds. Start it up. So this is what VS Code looks like when you start it. We've got a files menu here, search, some Git stuff, some debugging stuff, and extensions. So we'll search in the extensions for PlatformIO and install that. I'm not sure whether it's possible that PlatformIO will also try and install C++. Yeah, it does look as if it has. So once that's done, it'll ask me to restart PlatformIO so that the plugins are loaded properly. There we go, reload now. Let me just make this a little bigger. Okay, so what's next? So we've installed VS Code, and we've installed the 2 plugins. So I now want to create the PlatformIO project and choose a board. I'm going to choose an ESP32. So this window here is where you create new projects. If it sort of disappears, it can be sort of hard to find at first. You click on the face and then click on open, and you're back to this window. So give it a name and choose a board. I'll go for ESP32 dev kit. There we go. We've got a choice of frameworks, Arduino or Expressive IDF. Go for Arduino because it's what people know. And finish. So it's now going off and downloading the tool chain for ESP32. So this is the stuff that you need to program your ESP32. So the libraries that are provided by Expressive to do that sort of stuff. Okay, there we go. So we've got a project and it's got a main file. It's main.cpp rather than your sort of main.ino, so it's kind of a proper C++ class here rather than an Arduino sketch, but they look so similar that you probably won't notice. Okay, so the next step is to install the libraries. So I'll go back to here, click on libraries. I can search for Simple FOC, and what you can do is you can just click on install like one of these versions, but what I tend to like doing is defining the dependencies per project, rather than, because if you just install them in the way, if I just clicked install now, then it would install it in sort of some global space. So you can go to click on the installation tab, and then what you can do is you can grab the dependency here and then put it in your project specific sort of area. So this is like a named library, Simple FOC, but actually what I do rather than do this is I'll go to the Simple FOC or the libraries place on GitHub where you can get the clone address for the library, copy the clone address and pop it in here. Just I find it easier, and if you want to, and I do, you can go to a different branch in there. So saving that, what you'll notice then is that it basically goes and fetches that library for you and puts it in this .pio area. So we've got the source code for the library and all the examples for this particular library. So what we're going to do is we're going to copy one of the examples and put it, essentially replace this thing here. So I'm doing a kind of a search here, Control P to search for files, and then I'll look for the magnetic sensor analog. Basically both of my motors, both of my shields are set up for like magnetic sensor analog. Okay, close that for now. I know on my ESP32 that the analog pin is pin 34, so I'll just quickly change that. So to build it, it's Control-Alt-B. Yeah, okay, I saw this earlier. I'm not quite sure. This sort of this might be a bug in the FOC utils. I'm just going to kind of change something here. Where is this? So it's in source. It's going down to here. This doesn't actually exist. It's like an internal one. Doesn't exist in the library. That comes from Espressif, so I'll go to something that does exist. I actually need to check to see if it makes any difference. Okay, we're still getting a couple of compilation errors, and this is down to the fact that I haven't installed some of the dependencies. So I'm going to go back to here. Even though I'm not using SPI, I'm going to install the SPI dependency. I could have ignored this and it would have been okay, but I just like a clean build. There we go. So I can't remember whether I actually copied this. No, I didn't copy it. I'm just changing the example. So I'm going to copy this into my main.cpp. There we go. And I'm gonna. I've got the ESP32 connected to USB. So if I do Control-Alt-U, that will upload it. Okay, and then I'm going to do Control-Alt-S. So that looks a bit weird. So I'm going to close that. What's happening here is we've just got the baud rate mixed up. So I'm going to close that go back to PlatformIO, change the monitor speed. I think it's monitor speed. I always forget this. I'll try that one. 11520. I think it might be monitor speed. Let's try that, see if it's any better. Control S again. Yeah, that's better. So you can see the left one is the angle, the right one is the velocity. I've just been called for lunch. I'll be back in half an hour. Okay, I'm back from lunch. Thanks for waiting. It was chicken and rice if you're interested. So where was I? We're seeing a stream of angles in the serial. So I'll just see if I can get this. Oh dear. That's not so good. Basically the motor and its connections have come out of the board. So I'll see what I can do here. Just pop some of the leaders back in. There's only 3. Basically what we're dealing with here is it's a small gimbal motor. It's one of those sort of 7-pole, what is it, 2804, so 28 millimeters diameter and 4 millimeters sort of thickness, the motor. Right, let me just make sure I'm putting in VCC. Where's ground gone? Putting in ground, and the 3rd pin is the analog pin. So the gimbal motor, well, you can't see at the back of it there. You can't really see it, but there's an AS5600 in there, which is a magnetic sensor, and as the motor turns, the magnetic sensor goes from 0 to 1024. So like 0 is 0 degrees and 1024 is like 360 degrees, and if you turn it a bit more it'll go back to 0 again. Right, has that fixed it? Are we back? Yeah, we're back. I think it's misbehaving slightly. Oh, the ground's fallen out again. I think me moving this is a bit of a disaster. Yeah, it's working. I mean, you can basically see me turn in the gimbal and things happen. Okay, so we can see that's working. I mean, this particular sample is main.cpp. It's a bit, it's very simple. This is just doing, it's exercising a bit of the sensor library. The interesting stuff is actually happening in the sort of BLDC motor, but I haven't picked a complicated example because I don't really need to, because I'm just explaining PlatformIO. Okay, so that's that. So now moving on to, one of the good things about PlatformIO is that it supports multiple development boards. So I will, we've been dealing with the SP32. I'll go to my sort of gimbal controller here. So just stop the serial and I will click on our friend, back to home, and click on boards. So this gimbal board, I think it didn't really come with an Arduino bootloader, so I had to put one on, which is a bit of a pain, beyond the scope of this. But it's I flashed a Pro, what was it called? Arduino Pro Mini, and it's the 5-volt. I think it's probably this one. Yeah. So I'll click on that. This is opening up the sort of PlatformIO docs. So I want a new environment. I want a new environment for this new board. So I'll copy this environment. I will put it down. Go to the files here. PlatformIO. So we've got a second environment here. So the first environment is up there. I think you can do like this. That's like where your common environment stuff can live. So I'll pull these out and say that they're common. And then this is where I'll probably need to Google. some live googling here. What I want to do is how you're trying to explain how you toggle between environments. So you can set like a default environment to run. So PlatformIO environments, default, I think that's what it was. Maybe here it will explain it. Default env. Well, it looks a bit like it. So I think it was like this. I think you can have default env or envs. I'm just going to go for singular. This may or may not work. Apologies if it doesn't. So we want, let me move that bit here to be in the common. So both of them are going to be framework Arduino, both of them monitor speed 1152, both have the same lib dependencies, but they've got a different platform. It's basically a company that makes it, and a different board. So we were on the ESP32, but we want to go to the Pro. So if this works first time, I'll be impressed. So Control Alt U now. I didn't want to upload it actually, I wanted to do Control Alt B, so it's going to fail to upload. Oh, that's a bit weird. It looks as if it's installing the wrong code to the wrong. I think it's installing. Yeah, I've got my. I'm surprised that worked. It's uploaded. Oh no, it's doing both of them. So it's uploaded one environment to the ESP32 and the other to Pro. So it wasn't as bad as I thought. I haven't put the wrong code on the wrong one. So what I'm doing, I'm taking the USB cable out. And I've put it into the other board. I want to get this this environment thing right, because it's not right at the moment. It should have been. I want a kind of default envs. Is that it? Maybe that was. Maybe it does need an. Maybe it does need an S on the end, like it said. Default envs. Let's get rid of that. Okay, let's see now. So I've now got the USB cable plugged into my Mega, my Pro, whatever it is, and I will try and upload that now. So it's ignoring the ESP32, which is good, and it failed on the Pro 16. Ah, not this evil get sync jobby. Try again. No, I'm going to pause the video whilst I sort this out. Okay, I think I might have sorted it out. I think I had I selected the wrong Pro. There's a 168 and a 328, and I think I needed a 328 here. Let's give it again. I really don't like these AVR dude errors. They're just real pain in the ass to resolve. So let's see if that helped out. Control Alt unknown environment. Okay, so that's yeah. Let's pop that to 328 as well. Ah, that looks better, doesn't it? So it's ignored. You can see it's ignored one environment because it's not in the default envs, and it's built and uploaded the other environment. So if I do so it's already, yeah, okay, so here we go. Is this going to work? Let's try and turn it a little bit. Ah, it's not working. What? I know why it's not working. So we go back to the code. we're no longer on 34, we're on A1, and I'll upload that. Hopefully that will be the end of it. Okay, right, let's have a go. Yeah, so that's good. So there's other tricks you can do here, like I could have said like pin analog here, and then in PlatformIO I can define, sorry, I have to Google again, so this is dynamic variables. How do we do this? Minus D, there we go. So build flags, I'll grab some of that, so I could define a, just need the one, so we'll call this, what do we call it, pin analog. And what was he? This was for @mega, so he's the A1, and then obviously for the expressive one it's 34. So back to main, just upload that. Yeah, so that's still working. So that's the end of it really. Hopefully you've got a bit of a feel. I mean, one of the things I didn't show you was things like the IntelliSense here, and the ability to sort of click through, so you can go in and see what, you know, things are, and jump around, you know, like magnetic sensor. I can hover over it, it'll tell me a little bit about it, or I can click into it. I can go and have a look at its .h file. So that's sort of stuff you get kind of for free with VSCode and C++ editor on top of PlatformIO. So hopefully you guys have got something out of this. This is the first sort of video I've done like this, so if you like it, I think I'm supposed to say subscribe, like and comment. If you've got some ideas for like another video you want me to do, maybe go into depth on some of the sensors. I've got SPI, I2C and Hall sensors here that I could talk about, or some of the boards. Just let me know in the comments and maybe I'll put a video out. So I invite you to try the Simple FOC library and try it out with PlatformIO. See how you get on, let me know, and thank you for listening.